Hello guys, welcome back to another tutorial. Hit the bell icon button so that you don't miss out any tutorial.
All right, in this video, we're going to take a step away from our cancer rate data for just a couple of minutes and talk about exactly what is multiple regression. So we're already done with our exploratory analysis. We have our variables picked that we're going to take our initial attempt at modeling for, and we'll do that in the next video. But I just want to come out of the cancer data for a minute and talk more generally about what is multiple regression. So the first thing is that multiple regression is a model that depicts a linear relationship, I'm just going to write this down for you, between independent variables and a continuous dependent variable. Okay? And continuous is important. So when we talk about multiple regression, we're really talking about a continuous variable. There are other things for classification like logistic regression or multiple logistic regression. That's fine. And we'll talk about that in the classification section of the course. But for now, we're talking about continuous dependent variable. So for example, you might say that weight is equal to, I'm going to say B0, I'll explain what that means in a minute, plus B1 times age plus B2 times height, right? Plus some error, because no model is perfect. And so the BIs in this case are weights on each independent variable. Okay, so what do we mean here? Well, so we can think of, perhaps there's some, weight equals some constant plus a constant times age plus a constant times height plus error. And so you feel like age and height are good ways to explain weight. And so this is in a linear structure, right? This is a linear function. And so that's really all multiple regression is that, say you have some data on age, you have a data set that's a bunch of people, and we have their weight recorded, we have their age recorded, and their height recorded. And so we would attempt to make a multiple regression model to estimate weight based on a person's age or height. And so the act of creating a regression model simply calculates what is B0 and B1 and B2. In other words, what are the constants, what are the weights that go onto each of the terms? So how much weight does age get? How much weight does height get when they're used in a linear relationship explaining weight? And so that's really all we mean by multiple regression. So it's really the most basic model, very simple model, but is very powerful. Is very powerful. Okay, so let me show you some fake data. Let's use some fake data, and I'll just show you how this works in R, and then we'll in the next video we'll do it on our cancer data. Okay, so let's say we have some variable called x1, and that variable is I'm just going to make up some random data. Let's say 250 observations from a uniform distribution that's between 0 and 1. And then we'll say x2 is an input, and it's going to be 250 observations from a uniform distribution that runs from 5 to 10. Okay, and we'll say that y, the relationship for y, is that it is 25 plus 3 times x1 plus 7 times x2 plus some error. So we'll just we'll put in some random error. We'll put in some random error like that. Okay, and so what we'll do now is create a data frame. As data frame, we'll bind y, x1, and x2. All right, so let's have a look at fake data just so you can see what we're talking about. Okay, so these are all just random values, right? We picked random values for x1 that are between 0 and 1, random values for x2 that are between 5 and 10, and then we said y is 25 plus 3 times x1 plus 7 times x2. All right, so we defined that relationship. Now, in a regression problem, you don't know the 25, the 3, or the 7. All you know is you have a data set that gives you y, x1, and x2, and you want to predict y in terms of x1 and x2. So you have to figure out what's the right number here, what's the right number here, what's the right number on x2, right? What are the weights? And so the way we do that is with the LM function. All right, so the LM function stands for linear model. All right, so a linear model is the is the generic function. There are some other types of functions functions you can use in R. There's like a GLM function, but those are, if you need some more advanced modeling, you'll get into some of those. But for now, the LM function, and really for a lot of cases where you're doing multiple regression, the LM function works just fine. And so what we're going to do is model y onto dot. This is our formula syntax, y tilde, and then your input variables. If you put a dot, it'll just use all the other variables, and then we need to tell it the data set, which is fake data. And so we'll print out the results of YReg, and what you see then is we get the three weights, right? This output on our model is the three weights. And so we get a value of 25. The weight on X1 is 2.831, and the weight on X2 is 7.003. And so our regression model written out is y equals, now recall, we created the data, y was equal to 25 plus 3 times x1 plus 7 times x2 plus some error. And so here it's y equals 25.040 plus 2.831 times x1 plus 7.003 times x2 plus some error, right? Some unknown error. So you can see, and I'm just pulling those coefficients straight off the model output here. So the intercept is 25, that's the first term. The x1 weight is 2.831 and the x2 weight is 7.003. So you can see that our model, our estimated model here from the LM function, the regression function, is just very, very close to what we actually used to create the data. Okay, so you can see how powerful it is. The LM function has no idea what the relationship between y and the other variables are in fake data. But the mathematics behind that allow us to extract exactly what that relationship was. And so that's the work we do with non-fake data, so that we'll do it in our cancer data, is we'll use the same syntax, the same function, that LM function, to figure out what these weights are on our input variables, like the log income and the poverty percent and et cetera. Okay? So the mathematics behind that is really... you can check some other resources for that. It's some linear algebra and a little bit of calculus in the background allow us to figure out what those are. But that's the general idea and the structure of the model that we're going to create. So that's it for the introduction. Okay, in this video, we're finally going to create our multiple regression model for the cancer data. So if you recall a couple of videos back, we created our cancer final data set, and this is all of our 3,047 observations. We've whittled it down to just our dependent variable, and then we picked 3 independent variables that we felt like would do a good job. So we have the log of the income, we have the diagnosis rate, per capita diagnosis rate for each county, and then the poverty percent of each county. And so the first thing we want to do is split 2 training and test data sets, right? So the idea here is, if you're not familiar with that, is anytime you take your data set and you're going to create a model, you want to use part of that for training the model, and then you want to hold some of that data out and use it to test your model with. So you'll create model with part of the data, and then you'll use that model to run predictions on the other data that it hasn't seen yet, and that gives you an idea of how good your model is whenever it makes estimates on data that it's never seen. So let's go ahead and do that. There's lots of ways to do that in R. I'll just do a way that's a little bit manual, but it'll be explicit for what we're doing. It'll be really clear. So let's define something called the training size. So we're gonna round, we're gonna round 0.8 times the number of rows in cancer final. All right, so what are we doing here? Okay, so that gives us a train size of 2438. So what I want to do, in row of cancer final tells me how many rows are in cancer final. So that's 3,047, right? You can see that in the console. So what I want to do is, I like an 80-20 split typically for most data sets on training and test. So my training size is going to be 80% of 3,047. But that comes out to be a decimal, so I'll just round that up. And so whenever I round that up, then we get the 2,438. So of our 3,047 observations, 2,438 will be in our training data set. Now we need to determine which ones are they going to be. So train size gives us how many observations do we want. Train index tells us which observations. And so what I'm going to do is sample from n row of cancer final. With a size of train size. All right. And so we get our train index here is we have 2,438 values, obviously, and so we're given all of these random values, right? So the sample function selects out of the numbers up to 2,438. Selects from the 3,047. It selects 2,438 of those at random. And so now we have a train index. And so now we can actually create the data set, which is just going to be cancer final. And the way we'll do that is use the bracket syntax. And we'll say, give me all of the rows whose row numbers are in train index. So we did that. So train now is 2,438 observations of 4 variables. And then the test will be everything else. And so we want everything that's not train index, right? And so using that method, we get a training data set of 2,438 observations. We get a test data set of 609. So train is what we'll use to actually build our model on. And so the nice thing is, now that we've done kind of the intro to regression in our last video, this is really straightforward. Okay, so build the model. So here we go. So we will do cancer mod regression. Okay, and so we'll use our LM function. We'll say target death rate onto everything else in the data set, and our data set is equal to train. Data set equal to train. And so just that fast, it creates our model. So cancer mod reg. And so we see our output here, okay? And so we see, an intercept term of 497, almost 498, and then we see for log income and incidence rate and poverty percent what those are. And so, our model is target death rate equals 497.99 minus 40. I'm just going to do some rounding here, times log med income plus 0.23 times incidence rate plus 0.54 times poverty percent. Okay, and so here's our formula. Just like we did with the fake data in the previous video, we can write this out as a linear function. So here's our linear function to model target death rate. Now, there's if you use the summary function on your model, summary on cancer mod reg, you get some more detailed output. So a lot of this is very statistical. So we won't go through every, we won't go through exactly what this F statistics of 574.3 on 3 and 2434 DF means, or the residual standard error, degrees of freedom, that kind of stuff. But I do want to just mention the highlights here. The coefficients are really, this is the main meat of what you're probably looking for whenever you look initially at your model output. Now, p-values are not everything, but they are a good indicator. They're a good detective that help you know that you're headed in the right direction. So as we look in this last column, this is the p-value. So this is our statistical significance value. And of course, the lower that is, generally speaking, the more likely it is you have hit on a meaningful relationship. And so all of these values are extremely significant. You can see that they get 3 stars. 3 stars in our syntax means that they're significant under a 0.001 significance level. So they're basically 0. And all of these are essentially 0. I mean, 2 times e to the negative 16th is essentially machine error. The poverty percent is 2.4 times 10 to the negative 5th. So, you get a decimal with 4 zeros and then a 242. So Very, very small p-values. Clearly, we've hit on some variables that appear to have a pretty significant relationship to target death rate. Okay, so that's kind of the more detailed model output whenever you're looking at that. But really, creating the cancer model is just that straightforward. So we have a model now. We have a linear model that relates our 3 variables to our dependent variable of target death rate. And so that's all there is to it in terms of how to create the model and how to see the output.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.